Game and probability. Our game is rock, paper, and scissors. Losers, on the other hand, continue to change their conduct. They did so in the order of the game's name, starting with rock, then paper, and finally scissors. After losing with the rock, for example, a player was more likely than the 1 in 3 rule were expected to play paper in the next round. In game theory, this win-stay-lose shift strategy is known as a conditional answer, and it could help you win. They write that predicting this trend and thus outwriting your opponent will give her higher payoffs to individual players. A daunting issue for future research is whether the conditional response is a specific decision-making process of the human brain or simply a result of more fundamental neural processes. Despite the fact that it is a simple game, rock, paper, scissors is considered a useful model for researching competitive behavior in humans, such as in financial trading. In a previous study, it was discovered that players were uncooperative. A previous study discovered that players unintentionally imitate their opponent's behavior, which is shocking considering that benefit is typically gained by behaving differently. The probability of our game. Two players will show the rock hand in a game. Let X be the number of rocks, obtaining the probability of X. We use R for rock, P for paper, and S for scissors. S is equal to group of PP, PS, PR, SP, SS, SR, RP, RS, and RR. The formula of our game and probability is probability of two players show no rock, or PP, PS, SP, and SS. P times to X is equals to 0 and equals 1/2. Probability of two players show one rock, or PR, SR, RP, and RS. P times X equals 1 is equals to 1/4. Probability of two players show two rock, or RR. P times to X equals to 2 and 1/4. The first row of the table represents the possible values of X. The second row shows the corresponding probability of each value.